It's going.
There it goes. Okay, great. Thank you. Before we get started, we want just to get an idea who we have here today, right? Like, could you kindly, in the chat feature, post your name, title, where you're coming to us from? Thank you. Assuming folks could find the chat feature.
Yeah, if you're relatively new to Teams, the chat feature's right up on the top there. Great.
There
Hi,
we go.
Tony. Senior building inspector, great. Plan check engineer, building inspector. Tony, our fearless leader. Great. Looks like we've got a nice mix. This is the second time we've offered this presentation, so we weren't expecting a huge crowd this time around, but it's nice to see as many folks here as we've got. Los Altos, great. Welcome, Jay. Nice mix of inspectors, plan check examiners, and building officials. Fantastic.
Jackie, could you let us know what community you're from?
Okay, looks like that's pretty much it.
Yeah, great. Thank you guys for chiming in. Really appreciate it. As we move forward here, I just want to quote one of my favorite technologists from Silicon Valley. It's more fun to be a pirate to join the Navy. In that spirit, I want to keep this discussion somewhat informal. But that said, we also want to make sure we have a few ground rules just to kind of keep the conversation flowing. Thank you for remembering to mute yourselves. As we've noted here, that this conversation is being recorded and for later distribution. I see most of you folks have found your way to the chat feature. Thank you. If you have a question, there is also a raise hand feature. It's also right next to the reaction feature, so be cautious there. Lastly, we will be having a QA period at the end, but if something comes up, something can't wait. Josh says someone's struggling to hear me. Josh said he can't hear me. Can you? You having some challenges? Tony, can you hear me?
Yes, I'm hearing you.
Okay, maybe it's Josh. We're gonna blame it technical issues on Josh there. Thank you guys for chiming in. We sometimes have that. Technology is great when it works. I see you guys have found the chat feature. That's great. And like I said, we're trying to keep this somewhat informal, but I also want to make sure we've got an hour here. We've got a lot of information to cover, so we'll kind of keep things moving. Josh, are you back? He disappeared on me. Let's give him just a moment here. I'll move forward with the introductions. Today you have over 40 years of experience between Joshua and I. First, Mr. Pierce, Joshua Pierce is RHA's Executive Vice President. He's got over 20 years experience in energy efficiency, renewable energy, sustainable development, and construction management. He's also a former carpenter and general contractor, which explains his occasional outbursts and sense of humor. In his current role, he is responsible for technical services, innovation, and strategy at RHA. Next, I'm Brandon Blisman, an energy engineer here at RHA. I have 20 years experience in research and engineering support. In my current role, I research technologies, energy and building code requirements, which explains my occasional grumpiness, and help apply it to new program designs. Josh, are you back?
Can you hear me now?
We got you.
All right, great. Yeah, my little HD web camera that has the microphone just had to reset it. All good.
Oh gosh. Okay, great. Well, I'm going to pass the mic to you, and we'll go from there.
All right. get this show on the road here. Share my screen. Watch the presentation. Can everybody see the front slide?
Yeah.
Great. Okay. Yeah, well, thanks again for the opportunity to share some of our recent work with you today. Sponsored by Silicon Valley Clean Energy, RHA developed a couple of different guides to help municipalities, contractors, and homeowners address changes in the existing buildings market to increase the availability and equitable access to decarbonization retrofits. So we'll take about 20 minutes or today to talk about optimizing existing electrical service panels, kind of from a strategy perspective, and then Brandon is going to dive into the and actually show a few case studies. And why we will try and focus in this presentation on the issues from the perspective of local jurisdictions. Some of the information we're presenting here may be reviewed to you. We'd also love to hear your experiences and maybe even learn some new information and new insights from all of you as well, since you're out there doing the work every day. So we will be addressing this topic of optimizing electrical service panels in existing buildings, specifically when adding new electrical loads. So we'll kind of start with, what's all the fuss about. We talk a little bit about strategies for optimizing your peak electrical loads in buildings before you actually, as you're doing sort of your electrification design, or just adding any new loads. We'll talk about some technologies that we've used in other programs to help manage loads intelligently, which is also a strategy for reducing peak electrical demand in a building. And then, like I said, we'll jump into the codes, talk briefly about the different code sections addressing electrical calculations, and then show how we used different approved methods, California Electrical Code approved methods, in some of our case studies and what the results of that were. And of course, we can take questions at any time. We'll provide some time towards the end for Q&A as well. But feel free to come off of mute this is an informal, it's a relatively small group here. So you can either put your hand up. There's a little button up top where you can raise your hand, or you can just, if nobody calls on you, you can just come off mute. So before we get into the solutions, I wanted to just talk about some of the external factors that have been influencing this tremendous demand for electrification, and this shift that we've seen, especially here in California, although we're seeing this shift happening across the country as well. There's just a myriad of recent laws, regulatory statutes, and incentive programs, both local, state, utility, and federal programs intended to spur this market transformation away from natural gas and other fossil fuel use in California's buildings. SB 32 obviously is a significant one. That's the Global Warming Solutions Act of 2016 that is requiring the state to reduce its greenhouse gas emissions to 40% below 1990 levels. And we've only got a few short years left to meet those goals. There are certainly lots of others: Bay Area Air Quality Management District, the National Inflation Reduction Act, which is created the HERES and Homes program, which is coming through the California Energy Commission. Those dollars are flowing through and hitting California now, which is going to make another huge influx of tax incentives as well as rebates for electrification. And then, of course, upcoming changes, as you all probably know as well or better than we do, upcoming changes to the Title 24 that will go into effect in beginning of 2026, certainly for new construction, is also going to have an influence there. And this all kind of comes home to roost, really, in a building's electrical system. which, much like the grid, may or may not be able to handle this increased load without some work. And that's really the central issue that's facing contractors, homeowners, utility companies, and building departments is, more than 30% of California's homes, over 5 million homes in California, still have less than 150 amp electrical service panels. That's a big number. Nationally, that number is more like 60% that have lower than 200 amp service. So while it's lower in California because we generally have a newer building stock than folks back east, or in some of the large older cities in the country, we still have quite a few. And so with all this drive to electrify homes, how are we going to do this without upgrading every single panel, which, as we know, can be a costly and time-consuming activity? Well, there's some good news here. Recent studies have shed some light on this issue, and we've come out with some encouraging news here. Most electrical panels, even smaller capacity ones, have some room, at least, for new loads. This is a recent study that was done by HEA, determining that 86% of the homes that were measured had a peak load of under 50 amps, and over 50% of those had a peak load between 25 and 35 amps. And that was measured using, I believe, 2 years of advanced smart meter data. A pretty good indicator of where there is overhead and room for, even in panels that are 100 amps or 150 amps, to add a new electrical loads. And this information becomes all the more important, especially here in the Bay Area, where we're seeing the cost of electrical service upgrades, ranging from $10,000 and up, to actually replace the electrical panel with a higher capacity panel, go through the utility process. Oftentimes the utility may be looking to harden the grid, and they may be requiring that overhead lines get undergrounded. This can increase the timelines for folks who are wanting to do something as simple as put in a heat pump water heater or switch out their dual fuel heating and air conditioning system for a heat pump to 12 or more months. We've seen them as long as 24 months. So how do we do this? How do we go about the process? Before we start calculating electrical loads, what do we do from a design perspective? We realize this is not, solving this particular problem is not the responsibility of you folks as building officials and plan checkers or inspectors, but we wanted to share some of the things that we work with contractors and homeowners to implement when looking at minimizing the peak electrical demand of their building post-electrification, whether it's partial electrification or full electrification. And so this is just you call it a loading order. It's not necessarily exactly a loading order, but there's this strategy that we start with, obviously reducing heating and cooling loads where possible, by installing energy efficiency measures such as air sealing and insulation, to reduce the seasonal heating and cooling loads. Oftentimes we find that HVAC systems in California are oversized, and there's an opportunity, if you're going to switch that out, to do some electrification, and you switch that out for a heat pump to reduce your heating and cooling loads, downsize the system, which obviously is going to reduce the peak demand. We won't get into all the specifics of that, proper sizing of HVAC, et cetera. Not time for it in this course, and really not relevant. Just wanted to share that that's really where it starts here, is if you can make your building, especially your building envelope, more efficient, reduce the size of the new system you're putting in, you're reducing your peak demand as well as being more efficient. The next is selecting low power appliances. We'll get into some of those specifics, talk briefly about them. There are load management devices and strategies now, including energy management systems that are approved through the National Electrical Code for residential buildings. We'll talk a little bit about that as well. And then finally, once we've kind of done everything we can in designing our, let's call it this new all electric home, where we're removing these gas appliances, what's the right load calculations that we should use based on the home's configuration, to ensure that we're still calculating, we're still meeting all the code requirements, but not every code calculation methodology is appropriate for every house configuration. So Brandon will spend some time talking about that as well. Okay, any questions before I keep moving on? I'll just pause for a second. Okay, well,
I'm not
hearing
seeing
none.
anything in the chat either, Josh. I think we're good.
Yeah, it's all good. So yeah, as you folks probably know, because you're seeing a lot of them come through, or a lot more of them come through, heat pump water heaters are certainly having a moment. And while they're not without some limitations, they're certainly gaining both in popularity, reliability, and flexibility. That means, as in, there are more products available on the market. Notably, 120 volt, or what they're calling plug-in heat pump water heaters, have a much smaller inrush current than your traditional 240 volt unit with a larger compressor, and consume between 600 and 1,000 watts when they're operating. So significantly lower peak power draw as well as ongoing draw. They do have longer recovery times, so we always recommend that you significantly upsize the capacity of the tank whenever installing 120 volt. And we don't recommend them necessarily for every home, mostly for smaller homes or homes with fewer total fixtures. But it is a really effective tool. Another one is variable speed, even two-stage.
Hey, Josh.
But yeah.
Can I just add something to make sure people understand it?
Please.
The main difference between the 120 volt units and the 240 volt units with the water heaters is that there certainly isn't in the 120 volt units a resistance heater backup for when you need fast recovery. The 240 volt units normally do have a hybrid mode. The 120 volt units are pure heat pumps.
Yeah, thank you for that
240 volt
clarification.
units. Yeah, I leave mine in heat pump only mode anyway, so it would make no difference to me. Also,
right.
Please note in the photo that the heat pump water heater is not on the pedestal, and there's no bollards there, which is appropriate given the fact there isn't any combustion, so that if the water heater might not ignite flammable liquids on the floor. Thanks. Bye.
Yeah, great. Thank you. Although we did note this was from another program, and we typically require a pan underneath that, regardless of whether it's on a concrete floor or not. So I'm not sure whether or not they fixed that later, or maybe this was from a different program. Anyway, another one is variable speed inverters, especially for mini splits, but also for central systems. These have slow start mechanisms. These are inverter-driven heat pumps, much lower peak demand and running current than your traditional single or even two-stage condensing units. So another great tool. Always recommend that. They're also tend to be the highest coefficients of performance, so they tend to be the most energy efficient as well, especially in mild climates like we have here. And then I'll just mention, because there are some innovations happening in this space around dual utility heat pumps, where you have a storage tank, typically a larger storage tank, and heat pump that provides both domestic water heating as well as space heating through the use of a hydronic air handler. So these have been around for a while, but having them in super efficient heat pumps, typically it was a boiler or some other large gas water tank. These are relatively new, but we're seeing more and more companies coming out with innovations in that area. Okay, a few other examples would include induction cooktops, more efficient, safer, and very reliable compared to electric cooktops, and certainly safer than gas as well. They have lower peak demand than your traditional resistance cooktops, certainly gaining a lot of popularity. Some folks are resistant to them. We have had folks, well, who haven't wanted to install them in our programs. However, we've never had somebody ask us to take one out because they were unhappy with it. So there's a little bit of an adjustment period there. I switched recently to it, and I love my gas range, but I recently switched to induction, and once I got used to the slightly different cooking, yeah, I'll never go back. It's so easy to clean, and I can boil water in 2 minutes. They're pretty cool. We're also seeing a lot of innovations around heat pump clothes dryers, and even clothes washing and drying in one system. These also have significantly lower peak total electrical demand, peak demand than traditional units. They're more energy efficient as well, so they use less kilowatt hours. The one drawback is that they tend to have slightly longer drying times, but the technology here has improved dramatically especially in the last 5 years. And then I'll just touch on that. Oh, excuse me. Nothing beats the ambience of a wood stove or a gas fireplace, but when you are looking for a safer and attractive alternative, the water vapor fireplaces, as strange as that sounds, really have come a long way. I remember looking at them when I was still a contractor, and they were just coming out, and they were kind of funky looking and cheap looking. But I recently saw one in a house, I don't know, maybe 2-3 months ago, and until I got up close to it, I couldn't tell that it was a fire. I didn't know why they were running a fire during the middle of the summer, but it was just for ambiance. Okay, so that's the little soapbox on low power appliances. Moving down the loading order, the next step here is how do we manage our loads better? A really common thing we're seeing, especially when we're doing electrification with somebody that already has an electric vehicle or already has a dryer outlet in their garage, a really common thing is to put an outlet splitter in the garage. We'll talk about those. There's also individual circuit control units, and smart circuit breakers, as well as smart electrical panels. I'll just quickly touch on each one of those. So here's the smart splitter. We haven't really had any issues with jurisdictions not approving this. I know that some people do it and they just don't pull a permit because you're literally just plugging it into an existing outlet. But we typically always mention it because this is a super effective strategy. You're essentially taking the larger of two loads in your load calculation and taking one of those. So if you're adding an EV or if you're adding an electric dryer, whichever one has the higher draw current, that's what you plug into your electrical load. And this load splitter allows you to essentially run both of them, just not at the same time, right? So situation here would be your clothes dryer always takes priority. So if you're charging your car and you want to dry some clothes, it pauses charging your car until your clothes are dry, and then it switches back. And you can sort of prioritize which one you want to have priority. Individual smart circuit control units like a simple switch. There's certainly others. Just one example. We're not promoting any particular product here, just providing examples. This operates similarly. They can have also CT units so that you can do a little bit more refined monitoring if you want to. But it in effect acts the same way, just a slightly different configuration. Same thing with a smart circuit control unit. Again, provides you with the ability to manage two loads on a single dedicated circuit. And then finally, and at the top of the technology stack here, we're seeing more and more people selecting smart electrical panels. Some of these have load management capabilities. Many of them have load management capabilities. To the best of our knowledge right now, SPAN is the only one that actually meets the requirements for an energy management system calculated under Article 750 of the National Electric Code, which is, I think, going to be adopted in 2026 in the new electrical code. But if any of our code experts out there want to correct me, I could be wrong, but that's what I've heard. And this is really interesting. So I'll take just a minute to talk about our experience anyway with smart panels and using them for load management. So, and I think Brandon maybe even has an example from one of our projects. So this can be a really effective strategy where you've done everything you can, but your home is it just has over 100 amps. Let's say you have an existing 100 amp panel and your total load is going to be somewhat higher than that in your calculations. By using an energy management system that can specifically address the issue when the rare occurrence happens where you're going over 80% of the panel's capacity, it strategically shuts down individual devices or individual circuits until that moment, typically something that lasts from a few seconds to a few minutes, passes and the load drops back down. So that's just one example of other strategies that can be used with these smart panels. But we found that even with the increase of these panels, especially when you're looking at potentially undergrounding the service, if you have to do a service upgrade, as well as just the cost of doing the service upgrade, that these can even be a more cost-effective solution than using a standard 200 amp panel and doing a service upgrade. Okay, well that's it for my technology talk. I'll just introduce our next section here and then hand it over to Brandon. This next section we're going to be chatting about the electrical code, something you folks are super familiar with. So again, forgive us if some of this is review, but we want to talk about it through the perspective of having run these programs. So some examples of where we've used load calculation methodologies in the California electrical code in lieu of the most common one, which is, as you all probably well know, 220.82, and had some different impacts. So we'll briefly talk about 220.82 versus 0.87 versus 0.83, and maybe talk a little bit about energy management systems and the National Electric Code. And then we'll jump right into the examples. So without further ado, I will stop sharing my screen. Any questions at this point before we hand it over to Brandon? Tony, any additional thoughts?
Not for me, no.
Okay, great. Thanks, and Brandon, take it away.
All right, thank you, Josh. Let's see, we got 82, 87, 83. This really sounds like Brock Purdy last week and calling an audible at the line of scrimmage. So we're going to take this next few minutes to take a look at some use cases when these three most common load calculation methods are best used. 220.82. This is the default and really the only method for new construction. Just a second. Sorry, my Roomba decided to start right now. It was running behind me. Hopefully you guys didn't hear that. For master meter units and multifamily buildings, we typically rely on 220.84. 220.82 is a little bit more conservative in that it calculates 100% of the load, whereas 220.83 uses 80% of the load. And this can sometimes make the difference between being able to use the same panel or at least not upgrading the service feeder capacity. Next, 220.87. This is the one that uses AMI data, and it can be a very effective and accurate way to establish the remaining capacity. But there are a few drawbacks. We just want to highlight that there's some situations where this is impractical or just impossible. Things like low overhead capacity, the presence of solar. If you have solar, not allowed to use 220.87. There's also an interesting challenge around getting access to AMI data. Years worth is what is typically required. And finally, 220.83. In our humble opinion, it's best to use like 83 or 87, maybe a conjunction of those two, unless, of course, you're using an energy management system. The other thing that's kind of cool, I think is kind of cool, because I'm going to nerd out here for a little bit, is if you have access to a template or a calculator, the process is pretty quick. So what we suggest doing is comparing like 83 and 87. This provides us with two perspectives, and it can be helpful to, I guess, discern what happens when we're very close to the maximal allowable load.
Hey, Brandon.
Yes, sir.
I wanted to pause for just a second. I think we have enough time. I wanted to pause since we've got folks from a variety of jurisdictions here. I'm curious, do you typically provide some sort of a template to your contractors? And if you do, to do load calculations, unless they have them themselves. And when you do, what is that template based off of? Is it still typically based off of 0.82, or do you have different ones for the different methods? Love to hear from folks. You can either just come off mute or comment in the chat.
Yeah, hi, I'm Bill Todd here, City of Milpitas. No, we don't have a template. So for changeouts, typically that's not an issue as far as load capacity.
Mm-hmm.
New construction, like you pointed out, 220.83 is used. Our group has, especially our senior, well, he's a senior inspector who's charged with the electrical plan review duties, has had conversations in the plan review stage regarding these other alternatives for if you have a remodel addition or something like that. And Gary is his name. He's been, in fact, he attended this first session you had a while ago. And so he is being more proactive with starting that discussion. Obviously, we're not here to design systems, but having input has proven somewhat beneficial. It gets a little confusing when it's not so much pushback from the other side, but he was telling me that it's interesting the kind of discussions they have, which they're not against it, but they, you know how everybody has their rote things that they do. So kind of breaking out of the mold is basically, and trying to get them to go in a different direction with their calculation for load, and then the subsequent panel upgrade if needed, or whatever they're doing with load management. So that's about where we're at right now with it.
Great, that's awesome. Thanks, Bill. Appreciate that.
That is interesting. That's something we have experienced with some of our contractor network as well, right? Like, which is how we've been doing it. This is what works for us. But yeah, thank you for sharing. Is there anything else? All right, hearing none, I'll kind of move on to discussing the energy management system, NEC Article 750.30. This is what allows you to use energy management systems in buildings. Specifically, it defines the requirements for monitoring and controlling electric loads, making sure no overloading of the circuits or feeders at any time. Also connects with NEC 220.70, which defines the requirements for establishing a set point for the maximum continuous load. As Joshua was talking about, these things are pretty cool. You set a max load, reduces the available current to the circuits, like a dryer or an EV charger. Our experience, some jurisdictions have already adopted the language to make this streamlined for contractors and folks wishing to install these, and some jurisdictions just straight out forbid it. Have you guys had any experience with these energy management systems? Just curious. Kind of a shy crowd. That's okay. We'll keep moving.
Well, that might just reflect that they're not commonly seen.
That's very
Oh.
soon.
Oh, look at that. Tony says lots of spam.
Tony, thank you. That's great. Thank you. Thank you for confirming that. That's something that we have seen. It's they're up and coming, I guess is a good way to describe that, which is why we're having this conversation here. Thank you, Tony. On to 220.60. This is a unique way to use what we call the largest load, right? As we'll demonstrate in a minute, when we start talking about the use cases for circuit sharing or circuit pausing devices, the language right out of the code says where it's unlikely that two or more non-coincident loads will be used simultaneously, it shall be permissible to use only the largest load that will be used at one time for calculating the load on a service meter. In other words, you connect two appliances, the device only uses the largest load for the calculations. All right, this is where a lot of the rubber meets the road for us. We're going to dive into, and I apologize for nerding out here. I get excited about this stuff. If I start talking too fast, maybe just raise your hand, tell me to slow down. But I'm going to go into some of the use cases and some case studies here. Words are cheap, so we're just going to dive in here. We'll also get into the calculations and share the results and how we arrived at being able to fully electrify these homes. Here's the Davis residence in the Bay Area. Retired couple successfully upgraded all of their gas appliances to all electric on a 100-amp panel, avoiding the need to upsize their electrical service and spend possibly thousands, as Josh alluded to, for undergrounding their service. In this project, we had access to their meter data, the AMI data, and a peak of 4.9 kilowatts was noticed. Based on the equipment that's listed here, it's pretty consistent with what we've seen across different programs. They did have an electric oven, which is probably that 5,000 watt peak. Also of note here is they did not have air conditioning. Apologize, the slide is really busy, but it was really important for these homeowners to fully electrify. So we went to work doing load calculations. As indicated here with the red yeses, a red yes in this table means that a service upgrade would have been required for both 220.83 and 220.82. The load calculations did not pass, right? They would have required a service upgrade. But using 220.87, you can see we get a code compliant load calculation without needing to upgrade to service. Now, taking that same equipment and adding a circuit splitter to the dryer and the EV circuit, both 220.83 and 220.87 pass, right? That allows us to potentially use either of those load calculation methodologies and a circuit splitter and avoiding the need to do the service upgrade. It should also be understood that when in order to achieve peak demand in a house, every single appliance, light, plug load has to be running at the same time, which is rare unless there's a teenager in your house. So let's take a look, and we're going to get under the hood here a little bit of a load workbook. This is something we've developed in conjunction with the SVCE folks and adopted from a Bayrend load tool. I'm assuming you guys could see my screen here. I'm pointing to a spreadsheet. It's workbook here. We start over here on this README tab. Each of these load calculation methodologies has a step-by-step breakdown of how to use them. So there's the 87, the 83, and the 82. I'm going to jump in to that 83 for that Davis residence we just looked at, all of the cells in orange are inputs. And walking through this schedule here, this house was 1,800 square foot, the minimum requirements for general lighting load. Next is appliances. You enter a 1 over here. If it's used, if you're going to use the default, you keep it there. But if you got a different nameplate rating, the nameplate supersedes whatever the default value is. Moving down, we add the rating for each of the appliances, adding the loads for the air conditioning, and you could see using 83, it required a panel upgrade. We're at 104 amps and we only have 100 available. Jumping over to 80, using 220.60, right? We're here in the electric clothes dryer and the vehicle charger. The nameplate rating for the dryer was 5,700 and for the charger was 4,800. That code says that you zero out the electric vehicle charger and you put the maximum load. So we put this maximum load for the dryer in this calculation. And what do you know? Now we've got 12 amps of headroom and would not require, using the circuit positor allows us to not require a panel upgrade or a service upgrade for that matter. Any questions there? I know I went kind of fast. All right. Let's take a look at a couple more homes here. Here's the Kim's Bay Area residence. A family of 3 upgraded from gas to electric on the 100 amp panel. Here's a list of all the equipment and some information about this home. On this home, we were having challenges getting access to their meter data. Even if we had the meter data, it might have been a little bit close. To get there, we employed a smart panel. Again, indicated here in the red yeses, 220, 82, and 83 would have required a service upgrade. This is a great use case for energy management system using 220.70 allowed for the appliances. As Josh alluded to, the EMS prioritizes what we call the creature comforts or the non-negotiables, right? Heating and cooling and water heating, while cutting off things that are maybe not as needed at a certain times of the day, EV charging, clothes drying, that kind of a thing. Per the code, the EMS was set to a maximum draw of 19.2 kVA. Another thing to point out here is that smart panels are not for everyone. They do require additional customer education. While this customer was faced with the cost of an upgrading underground service and a 2-year delay, they opted for the smart panel. And finally, the Martinez home in San Mateo County. Here, a family of 4 upgraded from propane to all electric on their 100 amp panel. Here's some of their home information. You can see it was quite old, 4 residents. Another thing that's kind of interesting to note, the presence of electric baseboard heating. As indicated here in the table, just like the Davis residence, both 83 and 87 allowed for upgraded appliances without having to upgrade the service. Since they already had some electric appliances, it's also interesting to note that their peak load was about twice that of the Davis residence, leaving less room for new loads. Where we gained an advantage there was switching the electric baseboard heating to a central system, and we got some of that headroom back, as well as saving a ton of money on their utility bills. So here's a a list of all the resources that RHA has compiled. We provided a QR code here that's a link to the service optimization guide that we developed in conjunction with SVCE. There's also a shorter condensed version, which is a nice quicker read. There's also a contractor version and a consumer focused flyer. You can scan the QR code, and again, we'll distribute this slide deck to the folks that are on the call here a little bit later. There's also that template workbook that I shared with you as well, if you want to use that as a springboard to share to your jurisdictions. With that, I'd like to take a pause and open the floor to any questions. Feel free to take yourselves off mute, use the chat feature.
I'm curious to hear from folks, how much of this is review for you? Or did you, we'd love to get your feedback. Are there things that, was there new information that was introduced that was useful to you? Or was there something that you'd like to see us go into more depth, or maybe even spend more time explaining? Love to get your feedback on how useful this presentation was.
This is Taylor Brady with City of Mountain View, not related to what you just asked, but I am curious if you could expand on, kind of the rationales that people tend to follow in upgrading to a smart meter. Is it, always tied to the difficulty of, upgrading to higher service? Is it, because they want to install a lot more sort of smart appliances in the home? What rationale have y'all seen in your experience?
Yeah, that's a great question, Taylor. Thanks. Our experience is somewhat limited, and but it's growing. I kind of what I tend to see is people in one of two or three camps. So there's folks who want a smart electrical panel because they want a smart electrical panel. They like the coolness of it. They're doing a remodel on their house. Maybe they're doing electrification. Maybe they're just remodeling their house. And they like the idea of being able to, monitor their energy usage on their phone, and be able to control things. So there's those folks who are kind of the early adopters, that are doing it for their own reasons. And then there's folks who are doing it because it's a solution that's offered to them, typically by their contractor, or if they're a part of a program, like an incentive program where that's an option. That's sort of the other camp, is people who are doing it out of necessity. And within that group, there are definitely folks that I don't necessarily recommend it for. It does, like Brandon said, it does require some management of the system. And if you're not particularly technically savvy, that can be a little bit of a challenge. So especially with older folks who may not have necessarily grown up with computers and cell phones, and the internet, et cetera, and are resistant. So if they kind of lean in, then we lean in. But if they're very resistant and they just they're afraid of the technology, then that's oftentimes an important indicator. We don't want to be giving folks stuff that is going to be really difficult for them to use. Not great for the contractor, not great for the homeowner. Did I kind of answer your question?
Yeah, it does. That's great to know that there are those sort of two common paths to it. Definitely the former sounds like something you hear, especially with like energy storage systems or electric vehicles. So
right,
makes sense. But it's also just sort of helpful to know what alternatives we have for applicants in our case at the city. Thanks.
Yeah, thank you, Taylor. Is there any other folks that have anything they'd like to, like Josh was saying, is this new to you? Are we preaching to the choir?
No, it's not new. We are used to see other options when, applicants or homeowners, they don't want to upgrade the panels and everything. So, but very good, refresh all the ideas and everything.
Great, thank you.
Jackie.
Good morning. I have a question regarding the one slide you showed a span and then a Schneider. You didn't mention the Schneider. Is that something, the reason for that? Is that one not as good as the span?
No. I think every manufacturer has their own kind of features and things that they highlight in terms of the benefits and features of it. The Schneider panel is a perfectly good panel. They're a very reputable company. They make good quality equipment. Span is more of a tech startup. And so, Span's focus is really on the software and the energy management side of it. Where I think the Schneider system uses more like commercialized and known components and then puts them together in an intelligent way and adds some level of software on top of it. I'm not the one thing I believe is the difference between the two is that this may be different now, so please don't quote me, but at least when we were researching it, the Schneider panel was not UL 916 listed as an energy management device. So it was considered a smart panel, but it didn't have that specific 916 UL listing as an energy management device. It may now. They may have been in the process. But at the time, that was the difference between the two.
Okay, thank you.
Yeah, I have a comment here from Tony. I think we see a lot of this in our solar applications where an upgrade is not financially feasible, like Tesla's Powerwall 3. You see a lot of backfeed mitigation controlled through some sort of PCS system. Yep, becoming more and more common for sure, especially EVs and Tesla batteries and the like. Thanks, Tony. All right. Well, great. Certainly appreciate your feedback and your perspective. Thanks for joining in. Any last questions or thoughts? If not, we can give you back an extra 5 minutes of your day here and let you out of class a few minutes early. Okay.
Thanks, guys.
Thank you.
Oh.
Thank you so much. And you're gonna send us the presentation, right? Just to share with the team and everything.
Absolutely.
Great. Thank you so much.
Thanks, Joel.
Yeah, hi, Jay. Unfortunately, there are not CEUs for this yet. I like where you're going with that. Josh, is this okay to shamelessly plug another program?
Yeah, absolutely.
On a parallel path, you might consider checking out the San Diego Learn program. I can put the link in the chat here.
I'll put it in right now.
Okay.
Yeah, so we don't market this outside of San Diego because it is funded by San Diego Gas and Electric, but it's available to anybody in California. Anybody with a California zip code can go over to sandiegolearn.com. There is actually a series on avoiding electrical panel upgrades that Spencer Rosen's going to be doing. There's also some e-learning courses, lots of CEU opportunities in the San Diego Learn program. I think we've got 250 plus courses in there, and we typically run between 15 and 20 different webinars every month in that program. Hosted by lots of other subject matter experts, not all RHA.
Are they webinars timed or are they recorded and you can watch them at any time?
It's both. They're live webinars, and then typically, with a few exceptions, typically we record those webinars and then parse them out into 2 or 3 20-minute e-learning courses, so you can watch them at your leisure afterwards as well.
Our building officials would know more, but I suspect that doing something at your own leisure might prevent you from getting CEUs, so there's no one monitoring. I don't know.
Yeah, that's true. Not all of the courses offer CEUs, but whenever possible, we try and offer them. Typically, the live webinars are the ones that have the CEUs.
Yeah.
Okay, well, thanks. Got one more
I think
question. Is there
there's- I think
standard
we-
for inspection that you guys have seen incorporated so far to ensure that load shedding is doing what it's supposed to do? That's a great question, Tony. No, we have not. These things being so relatively new, every jurisdiction sort of approaches them a little bit differently, but specifically a test or some inspection to ensure that it's actually doing the load shedding it needs to do is not something that we have encountered yet. Not to say that some folks aren't doing it. It just hasn't been something that we have direct experience with. We'd love to help somebody put a protocol together, though. That makes a lot of sense. Tony, that's actually something for us to think about in the future. Make it a lot easier for local jurisdictions to be able to say yes to adopting 220.7 and NEC 750. If there was some sort of a checklist or set of recommendations for local jurisdictions for plan checking and final inspections, it's a really good idea.
Okay.
All right. Well, thanks everybody. Appreciate you tuning in. Thanks, Tony, for all your support and for hosting this and sponsoring this work. And hope everybody has a great day. Thank you, Brandon.
Thanks to you
Take it
guys.
easy.
Appreciate it.
Take care, everybody.
I